are some multiple choice questions that will be similar to what you'll see on your exam. Um, so which one of these variables is least likely to have a normal distribution? In other words, it should be symmetric. The mean and median should be the same. The area underneath the curve should be 1. Let's see. Annual income for all 150 employees at the high school. I don't know, it's a good candidate actually. Lengths of 50 newly hatched pythons. I don't know, maybe. Let's see. Height of 100 white pine trees in forest. Amount of soda filled in a weight 200. The same candy bar. What's the weight of candy bars? Least likely. So you want least likely.
Well, so I think the employees at a local high school would all kind of make the same amount. Pythons would have like an average weight. The trees, definitely the trees.
You agree with the trees?
Yeah, trees are like, because they could be like pythons or really
And it also depends on like the distance or size of each other, because if they're too close and they won't grow as tall. So, you know, like,
and what if they're all the exact same?
You think they're gonna be? Yeah, there's probably gonna be. So what you want to think of is which one's gonna have more variation, right? So let's take out the ones that we think aren't gonna have a lot of variation. So this one, there's not gonna be very much variation there. Not much variation here. Pythons, I don't think there should be very much variation in length of pythons. So what do we think is going to have more variation? Annual income for 150 employees at a local high school, or trees in a forest. I mean, when I look at trees in a forest, they kind of, I guess there is a lot of variation going on there.
Yeah.
Would there be more small ones than big ones? More big ones than small ones?
yeah, and then like teachers all kind of make like.
But it says employees, so there are some pretty low-paid employees.
But it's not like it's like a millionaire and then like you make like 50,000 a year. It's not like a big variation. Like everybody kind of like makes this, not like the same, but
Yeah, I think this has the most variation. Yeah. Yeah, you're gonna have some. Yeah. So I think that there's going to be a more difference in trees than in incomes, just because some teachers make what administrators make. So I think it's going to even itself out in the long run. All right, let's check out another one. Although the answer is actually okay. But I disagree with that answer. All right. The proportion of observations from a standard normal distribution that takes values larger than negative 0.75 is about standard normal distribution. So, what does a standard normal distribution look like? Looks like that, right? Where, one standard deviation there. But that's not really, that's just a picture of it. That doesn't really help us solve the question. What we need to do is either use our calculator or go to our table. and we're looking for the proportion of observations larger than a z-score of, let's see, negative 0.75. So that's maybe right about there. And I am going to shade the area so that I don't make a mistake and accidentally give the proportion less than that, right? So they're saying our z-score is negative 0.75. I will go to my handy-dandy table and find a corresponding where are you, table? Why can't I find you? Okay. Right. So we're going to need to go to our table, find a z-score of negative 7. .5. Negative 7. 1, 2, 3, 4, 5. It's this one. That little cool one. 0.2296 is the corresponding proportion, but that's giving us this, right? So this area is, what is it, 2266? That's that area, right? We got that from the table? But we want this area. So what we're going to have to do is go 1 minus 0.22. There's a trick also. I prefer you do it this way, but maybe some of you have already figured it out. But there's a trick to finding the opposite area, right? It turns out that this area here is actually exactly the same as this area. So if you don't like the idea of subtracting from 1, or you don't want to get out your calculator, you could actually go to your table. And let's actually calculate this first and then go to the table. I mean, doesn't it make sense that these two areas, that this area and this area are the same? It's not wrong. It's totally okay to do it that way. You do want to show on the AP exam, you do want to show that you subtracted from 1, or you want to say that these areas are the same. You have to somehow state your reasoning. So 1 minus 0.2266 is exactly 0.734. And I'll show you that you can take a little shortcut if you wanted to, and go to positive 0.75. And if you're not, I mean, if this isn't helpful to you, don't do it. But you'll see that you have at positive 7, 1, 2, 3, 4, 5, you wind up with this same, with that same proportion, 0.774, 0.772. It's going to be a little bit. I feel like I might have put the wrong number there. Negative. No, it's 260. Okay, let's do another one. Oh, let's see. Can you answer the question? What you see? Fantastic. All right. All right. This is a density curve. So clearly it is because all of the data is above the x-axis, or all of the area is above the x-axis. What else is true of a density curve? The area underneath the curve, or whatever, is equal to 1, right? So we know that this whole area of this rectangle is 1. What percent of observations lie between 0.5 and 1.2? So 0.5. What we want is this area, 0.5 and 1.2. Alright, so 1.2 minus 0.5, that is going to give me that length, right? So that's going to be point. And then we know that this height is 0.5, right? Given. So the percent of observations that lie between there is just going to be the area of this rectangle, right? Should be. So then we can find that out. Yeah. Okay. What's up? Okay. The distribution of heights of students in a large class is roughly normal. Moreover, the average height is 68 inches, and approximately 95% of the heights are between 62 and 74 inches. Thus, the standard deviation of height distribution is approximately equal to. Okay, let's draw a picture. I love drawing pictures when you can make let's just draw a straight line. Alright, whatever. Oh my goodness. I'm just. Okay. I feel more satisfied with that, even though it's not that great. Okay, average height, aka mean, looks like 68. 95% are between 62 and 74, so that means that this is 2 standard deviations above, this is 2 standard deviations below. Each of these represents a length or distance of 2 standard deviations. Okay, so what we really want to know is that spot right there. Yeah, this right here is 1 standard deviation. That's what we need to figure out, right? Where is that located? Well, isn't it true that this distance and this distance are the same? So then all I got to do is take and subtract 62 from 68, and divided by 2, right? Huh? 5 is this one? So 65, and really what this is just going to give us our actual length that we want, right? So 3. And I mean, we might as well fill it in since we have it. Yeah, so this is the answer. Right, because what I found was this length, and then I divided by 2, and it gives me the length of 1 standard deviation. Yeah? Alright. And there's some extra information there with the empirical rule.
Wait, then where did
Picture
you get 60? Oh, never mind.
of your empirical rule there. Okay. If a store runs out of advertised material during sale, it's either... Alright. Let's write down some information. So we're saying it's normal. The mean is 845. The standard deviation is 15. There's a 2.5% chance that a CD will be sold out. How many CDs should the manager order for an upcoming sale? All right. So we need to find an egg value, right? We're going to use all right, we don't know this. We know this. We know this. We've got to figure out this Z value. So at 2.5%, what is our Z value going to be? Let's find it. Huh? Yeah, so 0.025.
Oh yeah, and then my dog will just sit there.
Yeah, I saw.
There we go. Oh, perfect. Right there. Because we need a Z-score for that. And I'll finish the problem and then explain it a little better. I think it's going to be easier to finish the calculations and then explain where the calculation is coming from. So this corresponds to a Z-score of negative 1.9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1.97. All right. Let's draw a picture real quick. We can calculate this really easy. It's pretty simple. But what in the world is this question? Okay. Let's see, they're selling out. Let's see. Let's draw this picture. 2.5% chance that they'll all be sold out, and there's a standard deviation. Let's solve it. I think it's going to make it a little better. A little more solve. We'll go there. So. So I chose the wrong area. And let's look at it in context. Selling more than what you want doesn't look like that, right? Selling more than what you want looks like this. So I really wanted a z-value of positive 1.9. Good. Well, number. Cool. So I got thrown off by that a little bit, but it's not too hard to recover from. I was using the right method, but I chose this shaded area over here, right? Which, if we think about it in context, doesn't make a lot of sense, right? We're selling out of CDs. If this is the average number of CDs, the probability that you get more than, right, the probability of selling out is or not probability, but it does say chance, right? That's where we're introducing probability right here. But this is the proportion of times that you're going to be selling out, right? So you're going to be selling more. If I was going to choose over here, we would be looking at having CDs left over, right? So it was pretty easy to change gears and fix that. That's a pretty tricky problem.
So why is it?
All right, if your score on a test is at the 60th percentile, so the first quartile between the first quartile, the median, is an easier way to get it.
So you have to look at the z-score for that and see how many deviations it is, and then find out where it would be on the graph.
Well, this is weird. You're not below the first quartile, right? Between the first quartile, oh my gosh, I'm making this way harder by drawing normal distribution. This one we could figure out using some logic. Sorry. First quartile and the median. So is it between 25 and 50% of the data? No. Is it between 50 and 75? Yes. And fantastic. That's it. Okay. Got an easy one. All right. Students are sometimes graded on a normal curve. So this has to do with, this question has to do with transforming data. We got to know when we're transforming data that multiplying affects your measures of center and spread. But adding affects only measures of center, right? Your spread is going to stay the same. So, with that in mind, let's see. Class average on an exam was 60, standard deviation is 10. Which of the following is bound for a B? And percent of students who receive a B if the marks are actually. So we just need to figure out which scores are how many standard deviations above and below the mean. Small 16, 10. Bounds for a B. So let's see. 0.5 and 1 standard deviations. So above the mean. So 0.5 and 1 standard deviation above the mean gives us 65 to 70, you get a B. Right? So those are out. And then what we're going to need to find is the area of that shaded region. For the sake of time, I forget which one we're on. I guess we should do it. Let's use our calculator. Alright, so we'll go use our calculator. Our lower bounds, let's go to statistics. Distribution. Normal CDF. Our lower bound is 65. Upper bound is 70. Mean is 16. Standard deviation 10. So we're at approximately 1.5. Yeah, I typed something wrong. Let's see. So there we go. I believe I said 75. And then I wrote 70. And so now when we go to our calculator, it's going to make a lot more sense. And I can actually go through, copy, paste, and I can change my bound. And that's much better. 0.24173. That's U.S. presidents, approximately normal distributed with a mean of 54.6. Normal 54.6. Do we know our standard deviation? No, we know that we've been given an x value of 47. It said he's at the 11th percentile of the distribution, so we need to find a z-score at 0.11. Let's go ahead and use the calculator for this since we've been using the. So let's go menu, statistics, distributions. Let's go inverse normal. The area we're looking for is 0.11. Oh darn it, it won't out for us because we need our standard deviation. So we'll go to our table and we'll go for we'll go to 0.11 as close to it as we can in here. So we have a z-score of 1.2123. 1.2 negative 1.2. So z equals negative 1.24, and now we can use our normal calculation to figure this thing out. So we're going to have negative 1.24 equals x minus divided by our okay, so let's do some algebra. So we'll multiply both sides by sigma. And we'll go ahead and actually combine this all at once. So 47 minus 54.6 is negative 7.6. Divide both sides by 1.24. And we've got a negative divided by a negative, so we get positive 6. So we have to figure out why the discrepancy. Why did we get 6.13 and not 6.18? And let's go ahead and look at our z table. I have a feeling it has to do with this choice. So I chose this value of 0.1093. And I have a feeling that maybe this one is closer. So in order to figure that out, what I'll do is subtract 1 minus 0.1112 actually gives me 0.8888. And if I subtract 1 minus 0.1093, I get a value of 0.8907. So I chose the wrong z value. I should have chose a z value corresponding with negative 1.23. So this should be negative 1.23. And that's what's going to account for the discrepancy in this. But we still are able to choose this answer. It's definitely the closest. We know we did our work right. Just chose a value that was slightly off on our z table. Okay. Which of the following is true about all normal distributions? This is not true. There are areas under the curve greater than 3.49, but they're just very rare. The area underneath the curve is equal to 1. That's true all the time. So I like that one. The points at which the curvature changes from up to down are at the first and third quartiles of the distribution. That's not true. That's actually at 1 standard deviation away, right? That's what that definition is. And about 68% of the values of the variable are more than 1 standard deviation away from the mean. No, they're not more than 1 standard deviation from the mean. They're exactly 1 standard deviation from the mean. At the mean, the height of the curve is 0.05. This really depends on the distribution, so we're going to go with B. All right, last one. The 16th percentile of normally distributed variable has a value of 25, and the 97.5th percentile has a value of 40. Which of the following is the best estimate of the mean and standard deviation of the variable? All right. Okay. Well, it appears we have a system of equations on our hands because I see 2 unknowns and 2 two equations that we can make. So first of all, I need to figure out a z-value for the 16th percentile and a z-value for the 97.5th percentile. So, alright, sorry, 16th, 97.5. So let's find 16 under here. Hopefully I do a better job than last time and actually pick one that is the closest. So, point 1611 over here. So over here, I think, 0.1611 or more. Is that closer one? This one is 11 away from 16, and this one is 13 away. 13 hundredths of each other. I feel I'm gonna pick the wrong one. I'm gonna pick this one. So we're at 0.9. 1, 2, 3, 4, 5, 6, 7, 8. I just counted wrong on the last one. 0.199. So that'll give us our first equation. Negative 0.99. Sorry, 0.99. 0.99 is equal to 25, our x value. No. minus arm mean over our standard deviation. So now we're going to find 97.5. Here. 97.5. Oh, there's a nice one. Alright, so 0.9, 1, 2, 3, 4, 5, 6. 1.96. And now we have our equation that we get to solve. How long do we get to solve one? I don't know. Let's go ahead and take this thing and move it around. We'll solve for one variable, and then we'll substitute from this way. So let's go ahead and do that. So we'll multiply both sides by sigma. And I'm going to go ahead and subtract 25 from both sides. And let's go ahead and add. We don't want to know what negative mu is, we want to know what positive mu is, so we'll divide everything by -1, which will essentially change the sign in each of our terms on this side. Now that we have mu solved for, we can substitute that back into this equation. I'm going to go ahead and multiply both sides by sigma because I just don't like having a variable like down here. Now we can substitute 1.96 sigma is equal to 40 minus 0.99 sigma plus 25, substituting the value for mu in there. So 1.96 sigma is going to be equal to 40 minus 0.99 sigma minus 25, just distributing that negative sign. Let's go ahead and add 0.99 sigma to both sides. So 1.96 plus 0.99, that's going to give me 2.95 sigma equal to, and let's just go ahead and do 40 minus 25, or 15. We'll divide both sides by 2.95, and we'll get 0.08. Which I would like to see is 5. I think we just cancel these guys out. Boom. Boom. I like the feeling of forward progress there. So let's go ahead and now substitute this value. I'm going to go ahead and substitute it in here. It's going to be the easiest way to go. 0.99 times 5.08 plus 25 is equal to my mean. So 5 point. Actually, I'm going to go ahead and use that answer. It's going to be 5.03. Change plus 25 plus 3x approximately 30, which gives us, after a long time, I was able to cancel that one out too. And that is all. That was a doozy of a problem. But on your multiple choice section of any AP test, you can expect any bit of craziness to occur. Alright, thanks for watching. Good luck.